Hello U9 and welcome to a different kind of lesson today. We're going to be doing a video demonstration. You might be seeing a few more of these in the near future. So today is a bit of a test run. It's going to be new for you as well as for me, and we'll see how we go. If you have any feedback that you'd like to give, feel free to contact me via email. Alright, so today's lesson we're going to be looking at inequalities. So what is an inequality? We've been looking at equations so far. An equation is anything that has a left side, an equal sign in the middle, and then a right side. An inequality has a left side and then a different kind of symbol and a right side. So the symbols, as you can see, can be a less than sign, a greater than sign, a less than or equal to sign, a greater than or equal to sign, or a not equal to sign. And these are all considered inequalities because they're not equations. Okay, they do behave a little bit like equations, but in some ways they're also a bit different. Today's lesson, we're just going to get used to and familiar with these different symbols, and we're going to have a go at solving some of them. In the next lesson, we'll be learning some more systematic ways of solving inequalities. Let's look at these first example questions here. So we're going to write the following in algebraic forms. So that means we're going to be using symbols. So part A, 3 times a number is always smaller than 10. Well, we can write 3 times a number by just using a pronumeral. Let's use x, everyone's favorite pronumeral. So 3x. And then we're going to write is always smaller than 10. We can use our less than sign and point the smaller side towards the 3x and then write 10. So it says 3x is less than 10. So just remember, less than, the small side or the narrow side of the symbol points towards the smaller side. So that way we can be sure we've done it correctly. For part B, twice a number is larger than or equal to 8. So twice a number, we can just write 2x is larger than, so the large side now is going to point to that left side, or equal to 8. That's all we need to do for that part B. Part C. 4 more than 3 times a number is greater than 15. So 4 more than 3 times a number, we could say it's 4 plus 3 times a number is greater than 15. Easy peasy. Last example of this kind. Question D, 8 more than half a number is less than or equal to 3. So 8 more than half a number, let's go x divided by 2 is less than or equal to 3. Make sure the small side of the symbol is pointing towards the less than sign. All right, not too difficult. Let's move on to some different kind of examples. So is x equals 3, a solution to the inequality 3x minus 2 is greater than 5. So when something says a solution, so a solution is just, does it make the statement true? So does it fulfill the requirements of the inequality? If it does, then it is a solution. If it does not, then it is not a solution. So what we need to do is we need to substitute our value that we're testing into wherever we can in our inequality and see whether it makes the statement true. We're going to first find out what the left-hand side is for part A, and we're going to see, is it greater than the right-hand side? So the left-hand side is going to be 3, and then we replace x with its value 3 minus 2. So that's going to be 9 minus 2, which is 7, and the right-hand side we are given as 5. Now, because the left-hand side is then greater than the right-hand side, we can therefore say x equals 3 is a solution. So we found what the left side is, we found what the right side is, and we found that the left-hand side is indeed greater than the right side. So this value of x3 is a solution. It makes the statement true. Okay, part B. X equals minus 5. Is it a solution to the inequality 5 minus 2x is less than or equal to 6? So let's find what the left-hand side is. The left-hand side is 5 minus 2, and then in brackets we can put minus 5, which is going to be 5 minus, it's going to be 5 plus 10, which is just 15. And our right side is going to just equal 6. And so 15 is not less than or equal to 6. So therefore, x equals minus 5 is not a solution. So if it doesn't make the statement true, it is not a solution. Let's check part C. Is x equals 7 a solution? This time we have to substitute into both sides. So it's going to be left-hand side equals 3 minus 5 times 7, which is going to be 3 minus 35, which is going to be minus 32. For the right-hand side, it's going to be 2 times 7 plus 1, which is equal to 15. And we can say that, well, minus 32 is not greater than 15. So therefore, x equals 7 is not a solution. Okay, so we've got to think, does that solution or that value make the statement true? If it does, it is a solution. If it does not, it is not a solution. So our last set of examples here, we need to find a solution to these equalities using a guess and check method. So this is a very elementary way of finding a solution, but it's a start. So for part A, I've got to think of a value that's going to make that statement true. Let's just try a value. Let's make x equals 0. So we want to say a statement to indicate what value we're trying. So we say let x equals 0, and then we can do our substitution using that value. So left-hand side equals 5 minus 0, which is just 0. Equals just 5, sorry. And the right-hand side equals 10. So 5 is not greater or equal to 10. Whoop. So therefore, x equals 0 is not a solution. Okay, not a great first guess. Not a solution. Let's try another one, or let's think a little bit about what could work. So we want it to be greater than equal to 10. So let's try a negative number, because if we subtract a negative number, we're going to be adding. We want to get 5 to be bigger than 10. Let's try a negative number. So let's try let x equal -1. And the left-hand side is going to be 5 minus 7 times -1, which is going to be 12. And of course, the right-hand side is still 10. 12 is greater than or equal to 10. So therefore, x equals -1 is a solution. Now, for inequalities, there's actually an infinite amount of solutions that we can have in this case. So x equals -1 is only one of an infinite amount of solutions. You could have x equals -2, -3, -4, etc. And they would all work for that inequality. There's also an infinite amount of values that aren't a solution. So that's something to think about. Okay. Let's try part B. Let's think a little bit first here. We've got 3x minus 5 is less than 8 minus 5x. So we've got a positive value for x on the left side and a negative value for x on the right side, but we want the right side to be bigger. So let's try another negative value. Let x equal -1. The left-hand side equals 3 times -1 minus 5. So that's going to be -3 minus 5, which is -8. The right-hand side equals 8 minus 5 times -1, which is going to be 8 plus 5, which is going to be 13. So the left-hand side is less than the right-hand side. So voila, x equals -1 is a solution. So there's the introduction to inequalities. Have a go at those those exercises, questions given, and we'll see you in the next video. Stay safe.